Welcome to video 7.1. Before we get started, just a quick little warm-up. I got three different what's called polynomials written up here. Polynomial is a cool word. That's what this whole chapter is about. Nomial means terms, and poly means many, right? So polynomial means many terms. On the video that you watched after the test last time, it kind of told you that terms have like either addition signs, subtraction signs, or equal signs in between it. So how many terms do you see in this top line right here, my friends? One. That has a fancy name called a monomial. You don't need to write it down. Monomial means mono, one term. Nomial, I spelled it wrong. Nomial. Monomial. How many terms do you see right here? Two terms, just like your bicycle has two wheels and the bicentennial was 200 years. Bi means two, right? So a binomial, if I spell it right this time, nomial, so binomial. And this guy has how many terms? Three. Take a wild guess. He's not a binomial, he is a trinomial. Those are like the types of polynomials that have fancy names. Once you get 4 terms, 5 terms, 6 terms, they just call them polynomials because there's many terms with that. But the 3 terms that have like special names are monomial, binomial, and trinomial. Would you believe last time we did this on like our little assignment? We took a monomial and then we took it times some sort of polynomial in parentheses with the distributive property. Isn't that what your homework was about? You took a monomial times a polynomial. Today, a little different. What is this guy right here? This guy has how many terms? 2. That is a binomial. And is the other guy also a binomial? Cool. Here's how I'm going to teach it. Then I'll show you how every other math teacher in the world teaches it. I'm going to teach it with the distributive property, if you're cool with that. All right? So here's what I'm going to do. I'm going to erase all my cool stuff, and I'm just going to pretend, let me get my little pretend box right here, that that plus 4 wasn't there. Are you with me on that? Just pretend it wasn't there. Could you take that 2x and distribute it to the other parentheses? Yes or no? Let's do it. What is this? 2x times 5x. It's number times number, and x's times x's. So what's the number going to be? 10. And then x to the first times x to the first is x to the second. We are adding those exponents together. Are we okay with that? Then, don't we need to take 2x times 3 in that case? What would 2x times 3 turn out to be? And we will put a plus in front of it, right, because it is positive, right? 6x. Before we go any further, are you okay with me distributing that 2x to those two terms right there? Then, if you want to, lightly strike that guy out. You have used him. I am now going to realize that there was a 4 underneath there, correct? And you just distribute that 4 through the parentheses. So now I take this 4 times 5x. What's 4 times 5x? Positive 20x. Are we okay with that? And then 4 times 3, 12. Here's a cool little fact. Would you believe we took 2 dudes times 2 dudes? Would you agree with that? You should get 4 dudes back. If you take 2 times 2, shouldn't you get 4 in that case, right? So 2 dudes times 2 dudes is 4 dudes. The interesting thing that you didn't have happen to your homework is now looking at these 4 terms right here, are any of them like terms? They have to have the exact same letters raised to the exact same exponents. This is an x squared. Are there any other x squareds at all? Nope. This is an x. Are there any other x's? Yes. So right here, sometimes people like to underline them. I'm not going to make you do it, but some people like to underline them. You have a 6x and a 20x. Those are like terms. How many total x's is that? 26 x's. What we're going to do is we're going to put this final answer in what's called standard form also. Who's the biggest exponent you got in here? Like this is x to the second, this is x to the first, and this is actually x to the 0th. Are you with me that anything to the 0th power is 1? So it's like there's no x's with that guy. Who's the biggest exponent you got? The squared, right? He comes first, right? Big guy comes first. So 10x squared, got him. And then you told me that is positive 26x's, and then plus 12. This is the final answer. Yay! We are multiplying binomials times binomials today. Not exciting at all. It is just kind of like practicing for what we need to use this for in some future events kind of stuff. So we'll do it again. Just pretend that minus 11 isn't there, and let's distribute this 5a through the second set of parentheses. So 5a times 3a, wouldn't that be 15? And then how many a's would you have? A to the second. Are we all right with that guy? And then 5a times 2. Check yours with mine. I got 10a back. Is that cool? Then here's our arch enemy. This next number is not an 11. It is a negative 11. Are you with me on that? We've got to use the negative part. So a negative 11 times a positive 3a will be a negative 33a. Are we okay with that? It's a negative. And then a negative 11 times a positive 2 is a negative 22. Yes, no, maybe? Cool. Do we have any like terms to combine after that? I took 2 dudes times 2 dudes and got 4 dudes back. Do we have any like terms? 10 a's, negative 33 a's. Don't they both have a's to the first with them, right? And there's no other letters with them. So you can use a calculator if you need to. You know, we're going to add those up. So 10a and negative 3a is negative 23a's, right? Notice I started with my a squareds. That's what you care about. It's not these guys. These are called coefficients. Like the number in front of the variable, we don't care what order they're in. It's the a squared and then the a's and then this. Yes? Good question. The question was, when you combine these like terms, should it turn out to be negative 23a squared? Great question. That is a no, right? Because you only add the exponents when you multiply those together. Like it'd be like an a times an a would be a squared. So, cool. We've only done 2 of these, but have you noticed we took a binomial times a binomial, and like both times back, we got a dude with how many terms? 3? That's called a what? Trinomial. That won't happen every time. Happens probably 90% of the time, though, right? It all depends on if you have like terms or not. So let's skip on down to the next guy, number 3. Look at them letters, right? Aren't we dealing with like C's and stuff? So here's what we do. We are pretending that this first guy isn't here. Just pretend he's not there and distribute this negative 3 through the parentheses. What does a negative 3 times a negative 2 turn out to be? Positive 6. And here's where you have a C times a C, right? Because you're like multiplying those together. So C to the second. Are we cool with why that one became a C squared? Because you were multiplying the C's and stuff together. Then negative 3C times 6. I'm just distributing that guy right there. Shouldn't that be a negative 18C? All good in the neighborhood? Cool. Let's try that on the other dude. So now we have used this negative 3C. Hey, who am I distributing now? 4 or negative 4? He's a negative 4. All right, we're just going to take this negative 4 and distribute him through the parentheses. So that would be a plus 8C and then a minus 24. Are we cool with those 4 guys? 2 dudes times 2 dudes, you should get 4 dudes back. Just so happens that some of those dudes are like terms. Aren't those middle guys like both some C's, right? So what is a negative 18C plus a positive 8C turn out to be? How many C's? Negative 10 C's. Weird stuff, right? Not exciting one bit. You know, this is the nuts and bolts of algebra. Cool? All right. There's only a few. Like, please don't work too far ahead of me because the ones down at the bottom get weird, right? So check it out. Ooh, check out number 4 right here. Like, is it still a binomial times a binomial? This pink thing got 2 terms, and does this green thing got 2 terms? Are they like terms before I get started? Are x's and x squareds like terms? You have to be the exact same letter, x, raised to the exact same exponent. This is an x squared. This is an x to the first. Are those actually like terms? They are not. You know, they are not. So I can't clean these up at all. We're going to just do what we've been doing. We're going to distribute. Pretend that that guy isn't right there, and let's distribute. What is a 2x squared times a 5x squared? we will just do it one thing at a time. Number times number. What's 2 times 5? 10. And then x squared times x squared. Don't we add those exponents together? That would be x to the 4th. Cool? Then distribute this 2x squared to this 2x. Number times number would be 4. X squared times x to the 1st. Not x squared, but how much? X cubed, or to the 3rd, however you want to do it. Is that okay? Cool. Then we'll distribute this other guy. So I've used that 2x squared. He's out. Take that negative 3x. Negative 3 times 5, negative 15. X times x squared is x cubed. And then the last guys times each other, negative 6x squared. Once again, I like to check. Next time we'll get even messier, right? This is just starting off nice and small, but I took 2 dudes times 2 dudes, and I got 4 dudes back, right? It tells me I'm kind of taking care of everybody. Are any of these dudes like terms? The x to the what? 3rd? We got a couple of x cubes, right? We got 4x cubes and negative 15x cubes, so add them together. Again, putting it in standard form. The highest degree, first degree means like the exponent that you got until we learn a little more about that. So isn't that a negative 11x cubes, right? And then a minus 6x squared. Are we cool with that? No other like terms, because those first ones are x to the 4th, the middle ones are x cubes, and the last ones are x squareds. They're not the same thing. Cool. What's different about number 5? Not only does it have x's, but it also has what? Some other letter, in this case y. Who cares, right? One thing at a time. So we're going to pretend this first dude isn't here, and let's distribute. 2x times 4x. 8x squared, right? That's that one little oops. You know, it happens to the best of us, right? Then here we go. Oh, weird. 2x times 8y. Here we go. Number times number. What would you get? A positive 16. X's times x's. Well, this guy's got x's, but this guy does not. But the x's can't just go away, so they're there, right? And then this guy's got y's, and this guy does not, so the y's can't disappear, right? You cool, it's got to be 16xy. Awesome. Now, watch this move. The next thing that was going to end up happening could be the optical illusion nightmare for a lot of students. We're cool with those. Done with this guy. Let's take this times this. I'm going to do it in the same order I just did before. I did numbers, then I did x's, then I did y's. Are you with me on that? So, numbers first. How about 4? Are we okay with that? Then x's. This first little guy right here doesn't have x's with him, but this one does, right? So, shouldn't he have an x with him? And then this has a y with it, shouldn't it? And if you multiply it by this, it doesn't have a y, shouldn't it have a y? Are we cool with that? I'm going to stop right there, because I know I still got another move left. Are those purple things up there like terms? Yes, they are. But here's why I said the optical illusion. What if it was this? What if you did it out of order? Are they still like terms? The answer is yes. Does this have an x to the first in it, and this have an x to the first in it? Yes. Does this have a y to the first, and this have a y to the first in it? Yes. Do you like it when one of them says xy and the other one says yx? Your brains usually say, I don't like that. You know, I do not like that. I like to go in the same order every time. So if I've got some xy's here, I'm going to see if I can get some xy's the next time back, right? So, cool. There's one thing left, y times 8y. It is the most missed brain fart for even me, right? Y times 8y. 8 what? Y squared. Putting that little squared at the end is just like, for some reason, we're not so used to that, because it is 8 times 1 is 8, and y times y is y squared. We got us some like terms here, though, in purple, right? So we'll just start with what we had first. We had 8x squared first. What's 16xy plus 4xy is going to be? 20xy's. And then finally 8y squareds. So again, just kind of slowing down a little bit. It's got to have the exact same letters raised to the exact same exponents to be like terms. This has got x squared. None of these other guys have x squareds in it. This has got x's to the first. None of those other guys have that. And it has y's. So here's a quick question. What if I had 8x squared plus 8x squared y squared? Are those like terms? They both have x squareds in them. Are they like terms? They have to have all the same letters. So even though they both have x squareds with them, this one has a y squared with it. Does this one have a y squared with it? So not even like terms. And it's just new and weird. You will get so much better at it as we practice it, right? It's just like you got to have all the same letters raised to all the same exponents. So here's a quick one. 3x squared y to the fifth z to the third plus 2x squared y to the fifth z to the third. Are those like terms? You see how x squared, y to the fifth, z to the third, z to the third. All the same letters raised to all the same exponents. So when you add them up, you add these. You have 3 of them and 2 of them. Don't you have 5 of those total, right? 5x squared, y to the fifth, z to the third. Yay, algebra. Here's what I'd like to do. Let's see if you and a neighbor can get number 6 done. Pause that video, and let's see what we got. So I'm going to do 20x squared, boom, plus 15xy, done with you, plus 8xy plus 6y squared. Did you get the same 4 terms I did before you combined any like terms? Cool. Are there any like terms? Sometimes there's not. You know, we'll see that shortly here. Sometimes there's not. Are there any like terms? Yes, xy's. So 20x squared plus, how many xy's did you get? 23xy's plus 6y squared. Cool. Here we go. All right, let's do it again. Ooh, number 7. Hey, I got an awesome question. We are a bright group. In all the ones so far, we have had like terms to combine. Take a guess on number 7 before you do any math. Do you think we'll get like terms to combine? Something's different about number 7. What do you think? Yes or no? Like terms? Let's find out. Let's multiply. This guy right here, 4x times 2y would give you what? 8xy. Cool. Then you take this 4x times this negative 7, and you're going to get negative 28, anything else? X. Are we okay with that? Then we're done with him. Taking 5 times each one of these guys. 5 times 2 is 10, and then we get us a y to hang out with it. And then how about a minus 35? 2 dudes times 2 dudes, I got 4 dudes back. Are any of those 4 dudes like terms? Nope. This is an xy. This is only an x. This is only a y. And this is called a constant. No like terms. That's your final answer. What was different about him that made me know, just by looking at it, because I got experience, not going to get any like terms? First binomial had x's. Second binomial had something else, not x's. Are you with me? So let's look at the next one. Does this have x's with it? And this have x's with it? We're probably going to get us some like terms to combine, right? So let's multiply this out. (16x) or 16x squared? Yeah. Just watching that little exponent. And then, so that was this. And then here's this. Minus 20x. That's the first 2 dudes. And then plus 20x minus 25. 2 dudes times 2 dudes, I should get 4 dudes back. Are any of them like terms? Yes. These guys. Uh-oh. What is a negative 20x? plus a positive 20x add up to be 0 x's. Mathematically, should we write down 0 x's, or do they just go away? They're gone, right? So far, we have taken a binomial times a binomial every time. In the first 6 problems, we got a trinomial back. Then on the 7th problem, we got 4 terms back, like a polynomial. Then on the 8th one, we only got 2 terms back. We took a binomial times a binomial and got a binomial back. So, like I said, about 90% of the time. Now, so what we have done is use the distributive property to figure this out. Here's what every math textbook teaches you to do. It is called FOIL. Maybe you even remember that from 8th grade. Don't know if you've seen that or not, but FOIL is an acronym for first, outside, inside, last. Here's a quick question. On this binomial right here, who is the first term? 5w. In this binomial right here, who is the first term? So in FOIL, you should take the first terms times each other. Isn't that what we did anyway? We took this times this, right? Isn't that our move, right? So let's kind of work together here. That's 20w squared. First stands for, or F stands for first terms times each other. O stands for outside terms times each other. How do you feel about this and this being the farthest outside terms? Are you with me on that? Isn't that what we did anyway? We took this times this. Are you with me on that? We did that anyway. So that is a negative 45w. And I'll bet you're smart enough to know if O stands for outside, take a while, guess what I stands for? Inside. Doesn't that mean you take these two guys? They're the closest inside to each other, right? Times each other. So that's minus 8w. And then L stands for last. You take the last term in each group times each other. Is this negative 2 times this negative 9? What's negative 2 times negative 9? In 20 years of doing this, I have seen students do really well with FOIL, and some people are like, I can never remember the order that you want. I don't know who the outside guys are, or who the inside guys are, or who the first guys are, or who the last guys are. We had a little recording issue, so if we see this twice, sorry. But to square a binomial, like, it means you got to take it times itself. So we're trying to take 2x plus 6 times 2x plus 6. So I like to scratch that guy out, and then we'll multiply them out. 2x times 2x is 4x squared. 2x times 6 is 12x. Then I'm done with him, and now I'll distribute to this other guy. 6 times 2x is 12x. 6 times 6 is 36. Got me some like terms right there. So I got 4x squared plus 24x plus 36. Then, same thing here. You've got some sort of thing being squared. That means you need to take it times itself. So I scratch out the squared and just write the same parentheses times itself. And then I multiply. It's called expand or FOIL. 25t squared minus 5t. Done with him. These guys, minus 5t. And then plus 1. Watch that 1 times 1 being 1. Combined in my like terms, minus 10t. And then the last one, it is a quantity squared. Scratch that guy out and take him times himself. First guys, 16b squared. And then the last guys times each other, negative 32b. Uh-oh, I hit a button. There it is. Sorry about that. I kind of hit an accidental button. Then we'll do this times this. That'll be a minus 32b. And then negative 8 times a negative 8 is a positive 64. And then when you combine like terms, 16b squared minus 64b plus 64. Yeah! On the homework that you have, there's lots and lots of review. So please look at the top of the question. There should be like a little indicator of what lesson it came from. And let us know if you have any questions. Have a good one.